Let's talk about something every single .NET developer has to master: validation. We're going to go on a journey from that very first simple app you build all the way to designing a massive system that's like a fortress for data. So let's dive into the 10 ways you can absolutely nail validation in .NET.
But first, we have to start with this question, right? The big one. Is the data flowing into your application correct, and is it safe? Because if you get this wrong, you're not just looking at bugs, you're looking at corrupted data, security holes, the whole mess. Getting it right, well, that all starts with solid validation.
Every developer's journey has a beginning, and for pretty much all of us in the .NET world, that first line of defense is a tool that comes right out of the box. And that tool is data annotations. You can think of these as little tags you just slap right onto your model's properties. You see it in the code there. You just decorate your property with something like required or email address in those square brackets, and ASP.NET Core just handles it. It's super clean, really easy to read, and honestly, it's the fastest way to get started.
So here's the deal. You got to know when to use them. They're perfect for simple DTOs, those objects that just shuttle data into your API, and anytime you need something up and running fast. But, and this is a big but, as your app gets more complex, you're going to hit a wall. These rules are static, they're a pain to unit test by themselves, and they have zero support for dependency injection. So if you need to do something like check a database to see if a username is already taken, yeah, data annotations just can't do that.
And that's the moment a developer levels up. When the rules get tricky and your architecture demands more flexibility, you graduate to what is, for sure, the industry standard for validation in .NET.
Say hello to FluentValidation. This is a completely different philosophy. Instead of sticking attributes on your models, you create a whole separate class just for validation. The logic is all C# code, and it's written in this, well, fluent way. You can literally just read it out loud. There's a rule for the email. It can't be empty, and it has to be an email address. This completely separates your validation rules from your data models, which is a huge win.
Now let's put them head to head. I mean, this table says it all, doesn't it? Data annotations are simple, but FluentValidation gives you all the power where it really counts for a serious application. It's testable, it plays nice with dependency injection, and it can even handle async rules. These are all things you need to build a system that can scale and that you can actually maintain. This right here is why senior devs reach for it almost every time. Okay, but a real pro doesn't just have a hammer and a saw, right? They've got a whole toolkit full of specialized tools for very specific jobs. It's the exact same thing for a senior developer in validation. Beyond those two big ones, there's a whole world of specialized techniques.
And this is that toolkit. Let's run through these real quick. If you need a custom rule you can reuse everywhere, you build a custom attribute. If you need to validate multiple properties against each other, like making sure password and confirm password match, you use iValidatable_object. For really complex business rules, you can just do manual validation right inside your service layer. And for the big picture stuff, middleware can check things on every single request, while client-side validation gives your user that instant feedback in the browser so they don't have to wait. See? A different tool for every job.
So, we've got all these tools. Now what? How do we put it all together? This is where we have to stop thinking like we're just writing lines of code and start thinking like an architect. We're not just building a single wall here, we're building a fortress with layer after layer of defense.
And this is the blueprint for that fortress. A request comes in, and it has to get through all these layers. The client gives you that immediate feedback. Then the API gateway, that's our main gate, is guarded by FluentValidation on our DTOs, rejecting any obviously bad request right away. Deeper inside, the service layer checks the complex business logic. Then, at the very core, our domain models protect themselves. This means an order object, for example, can literally never be put into an invalid state. And if all else fails, the database itself is the final safety net with its own constraints. That's what we call defense in depth.
All right, let's do a little lightning round. Think of this as the Q&A you'd get in a tough technical interview with a senior developer. Let's hit some of those big questions.
First up, the question everybody asks when they see all these options. Which one is actually the best one to use?
And the senior dev answer is always going to be, it depends. There is no single best tool. The best approach, the professional approach, is to match the tool to the task. Slap data annotations on your simple API models to get things done quick. Use the power and flexibility of FluentValidation for anything remotely complex. And always, always protect your most important business logic with validation baked right into your domain models. Next question, and this one really gets at the heart of good architecture. It's not just about what tool you use, it's about where in your application you actually put it. And the answer is, validation lives everywhere. You layer it.
If you only validate at one spot, like your API controller, you've created a single point of failure. A truly tough, robust system validates at the edge, it validates in the middle, and it validates at the core.
Okay, now for a really, really important one. This is a trap a lot of people fall into. If my validation is perfect, does that mean I can stop worrying about security threats like SQL injection?
The answer is a huge, emphatic no. They are not the same thing. Look, validation is about making sure data is correct. Is this a valid email format? Security is about making sure data is safe. Does this input string contain a malicious script designed to wreck my database? They're related, for sure, but they are two different jobs. You absolutely need both.
So if you only remember one single thing from all of this, let it be this golden rule right here. This sentence is basically the whole strategy. You layer your validation. You use the right tools, like DataAnnotations or FluentValidation, at the API boundary, and you protect your core business logic deep inside your domain. That's it. That's the secret.
And that brings me to my last question, and this one's for you. Go look at the code you're working on right now. Think about that fortress blueprint we talked about. Which one of those defensive layers are you missing? Thanks for joining me.